Okay. Hi, this is Alan. He's sort of our most experienced builder guy, and he's just going to show you what we're doing with the ISO board and the insulation system.
Yeah, so Chris, what we have here is we have a 2x6 standard wall with half-inch plywood on the outside, then we fastened 1.5-inch ISO board to the outside of that. Over top of that we'll have a 60-pound black building paper, and then we'll have a rain screen 1.5 inches by 1/2 inch wide, treated, salt treated strips to form the rain screen. Around the windows we'll have on the bottom we'll have a special sort of rubber stretchy membrane that goes around the corners into the corner parts. Then we'll have a peel and stick that goes on either side of this, and it gets split here in the center and goes up about 4 inches on this side. Then we'll be wrapping 60-pound building paper and wrapping that, shingling it up to form the seal for the window. Before we put the window on, we'll have caulking on 3 sides of the windows, and we'll have a special 1/8 of an inch shim that keeps the window out away from the building 1/8 inch at the bottom to allow the water to flow through. And the window at the back side will be supported by a 1/4 inch shim to keep it up from the sill of the window itself. So that's the system for window installation and getting ready for siding.
This is Shane, our Cordwood expert. He's going to take us through some details of how the wall, the corner, and the window went together.
Hi. So this is a Cordwood masonry wall. This is an exterior section undercover, but what we have is a 16-inch log that goes all the way through the wall. We have a 4-inch mortar gap, and I'll explain the mortar in a little bit about the composition of the mortar. We have a 4-inch mortar gap on the exterior and a 4-inch mortar gap on the interior, with a somewhat of an 8-inch insulation gap through the middle as a thermal gap. The wood is all cedar, either yellow or red cedar. The window box is obviously built in with also with a thermal bridge of insulation in here, a thermal gap to break the thermal bridging. The insulation itself is cedar sawdust and Portland, or rather builder's lime, mixed together with some moisture added so that the lime will set up over time into a bit of a foam matrix with the cedar saw chips, so that there will be less settling over time in the insulation of the wall, which tended to happen with insulated walls where the cedar was the main component. On the corners here we have what are called coins. We didn't have a way of tying the corner in the building together properly. There's a timber frame structure behind this. These coins would be necessary in a building without a timber frame, but they also became necessary for us with this hybrid style building, because again, we didn't have a way to bring the cordwood out to the corner and then go return the corner back. So we used an old design principle to wrap around the timber frame. So really we've got a doubly built corner, very overbuilt corner, which makes our engineers very happy. As for the mortar mix, it's composed of builder's lime, Portland cement, fly ash, sand, and cedar saw chips soaked in water, which will retard the drying process of the Portland cement. So the water-soaked sawdust is right inside the mix. It's probably hard to see on this videotape, but there are little bits of saw chips that are showing through here from pointing. Yeah, so basically these wet saw chips feed the cement mortar water as it's drying out. And if you have a good ratio, you get very little cracking. If you have a poor ratio, you start to get a little bit more cracking. And we trained a lot of people on this wall. So there's various places where there's a little bit of cracking, and some places where there's no cracking at all.
And then the window construction. So you have these lintels above the window?
Yeah, I wouldn't do this again, this method. I would, but generally what we did is we added a lintel, mostly for aesthetics, but also because I like the idea of the load of the window being carried out wider. We invented this window box over time. It took us 4 or 5 times to get it right. But this one we set it out 3/4 of an inch so that it would match up with the trim boards that actually go on with the window. We have to cut in a flashing actually underneath this lintel, and this is why I wouldn't do it like this again, because the rain will run down here, hit the window, and then tuck in behind. So we have to put a flashing line in here. Now if I were to do it again, I would bring this lintel right down onto the top cap, and you get rid of this 2x6 at the top, and so that this would be an integral part of the window frame itself. But we do have we're probably going to have the warmest window boxes in the valley because of this big, huge gap that we were talking about before. So whereas a standard conventional wall is going to bleed energy in through the wood, in and out through the wood, the cold air and cold temperatures will penetrate through this wood. As soon as they get to this gap, it's stopped in its tracks. It can't really penetrate any further. And so the warmth or the coolness of the interior will maintain that temperature, whereas this will maintain that temperature on the exterior. And that's our hope.
Okay. Here I just wanted to, I don't know how visible this is, I just wanted to capture the overhangs here. So Shane, how far does the skirt roof come?
The top overhang is 3'9". Well, it's actually 3'6". 3'6" overhang on the top, and slightly less here. I can't remember quite because the skirt is actually buried into the cordwood and married to the timber frame. But I can see from here that line is roughly a foot less, so it's about 2.5 feet for this secondary skirt line.
So the skirt roof's on the plans, and it's about 2.5 feet, and then beyond.
And it's also flashed right into the coins through the.
Oh yeah, here you can see. I think I can zoom in, and you can see how he's installed the flashing there.
And we also have accompanying photographs to go along with